In the event of a cardiac arrest, chest compressions and ventilation should be performed as quickly as possible. All professional societies agree on the fundamental goals of resuscitation. The first goal is to maintain a minimum circulation. This is done by means of chest compressions, ideally without interruptions. The second goal is the oxygenation of the internal organs, especially the brain. To do this, sufficient ventilation is required. In addition, ventilation ensures adequate alveolar ventilation. To achieve these goals, we have developed Chest Compression Synchronized Ventilation, CCSV. Until now, chest compression and ventilation during resuscitation were considered completely separately. However, every chest compression affects the air volume of the lungs. The same compression that pumps blood through the circulatory system also presses air out of the lungs. This causes a reduction in intrathoracic pressure. During the decompression phase, blood flows back into the heart and a small amount of air enters the lungs. During resuscitation, under CCSV by contrast, the heart and lungs work together. The thorax supports the heart. This happens because mechanical breath is delivered synchronously with each chest compression. In this way, the chest acts as an abutment for the heart. Thus, a higher pressure is exerted on the heart and more blood is pumped through the circulatory system. In the decompression phase, the air once again escapes from the lungs. The venous return to the heart can occur unhindered. The key difference to conventional ventilation is the increase in intrathoracic pressure in the compression phase. As a result, the heart is compressed to a greater degree and cardiac output is increased. Studies show a significant improvement in blood pressure under CCSV. At the same time, the oxygenation of the blood is improved. In addition, the elimination of CO2 is improved in comparison with conventional ventilation. This prevents acidosis and the pH value reaches a normal level.
CCSV can be easily integrated into MEDUMET Standard 2 as a software option.
Key parameters can be seen at a glance, such as the compression frequency and the hands-off time. In the absence of compressions, such as during shock delivery or after ROSC, ventilation is paused automatically. Upon resuming chest compressions,
MEDUMET Standard 2 automatically switches back to
CCSV mode. Chest Compression Synchronized Ventilation, synchronizing the hearts and lungs during CPR. You can find further information on our website.